First thing I'll pitch, we did have the first class this morning, but there's still time for you to enroll. If you are interested, we're starting a game programming major in computer science, and we have a course CSC275, which is game programming 1, meets Tuesday mornings from 8:05 to 11:20. The preference would be for you to attend the class. I'm sorry, 8:05 to 9:20. Sorry. Just rolls right through this class. 8:05 to 9:20. The preference would be that you would actually attend class, but it is an option to watch the videos and do the homework assignments. The prerequisite for the class is CSC 200 with a grade of C or better. So if you have had 200 or have credit for 200, like in your case, you might want to take that class if you need credits or are interested in game programming stuff. It should be a fairly interesting class. We're going to be using the Unity game engine in there. If you are going to enroll in that, let me know after class today so I know how many more people to expect. First homework assignment is already up, but it actually is identical to the first one in here, so you haven't fallen behind so, at that point. But I would recommend it for any student that is in here. The one caveat is with minimal exceptions, you can't drop another computer science class to pick up that class. I guess if you need to drop another CS class to take it, check with me first, because we need to look at that class and make sure we're not under enrolling a different class to enroll that class. So, but in general, if you have a slot open, I think it would be a pretty interesting class to take. Okay, so having said that, if you're looking for the CRN, it's on Slack. So it's on the main Slack page in general. You can get the CRN for the class, and then let me know if you aren't able to attend the class in person, and we can make arrangements for quizzes and stuff like that. This fall is when Game Programming 1 will be offered. Game Programming 2 would be offered next semester, and then Game Programming 1 again will be offered a year from now is I think the plan. I don't want to promise that, but that's the plan. Yeah. So I would say if you're interested in the game programming stuff, the time to take the class would be now, because then you'd benefit from the next classes we'll have. So next fall, you would take the third class instead of taking the first class. Yeah. Would be the idea. Okay, so this is 250. So prerequisite for this is 200. So everybody in here should have either had 200 or credit for 200, one way or another. So this is a continuation of that class. So what is 200? 200 is kind of an introduction to computer programming in general. The idea is that you come out of 200 with let's call it a intermediate minus skill set in computer programming. Doesn't matter on the language, just you have that skill set. In here, so the language we most recently taught in 200 was Python. In here, we're going to be starting to use Java right off the bat. So whole new language, so any of your Python stuff syntactically isn't going to help you, but the programming experience you got from that will certainly help you with Java, and we'll see how quickly we get up to speed with it. If you remember something I said in 200 along the lines of all programming languages have facilities for, well, the way human beings solve problems is we remember stuff, we ask questions, and we do repetition, right? And 100% of programming languages have facilities for those three things. So Python allowed you to create variables. Python allowed you to create conditionals. Python allowed you to do loops and recursion and write functions, that kind of stuff. Java does the same thing. All right, so it's going to be about applying that knowledge from programming as a skill set to now another language, Java. So we're going to start off by using Java, just the core language. And then sometime, probably around midterm, we'll segue into writing Android applications. So we'll be doing mobile applications in Android, also using Java. So Java being the core language, but we'll then learn another skill set of creating interfaces for Android mobile devices, and that'll then also give the opportunity if you want to write apps for the Google Play Store and sell those apps and that kind of stuff if you want to make some money on the side. Similarly, that skill set you're learning in Android development can be directly applied to iOS development. If you're a Mac person, you can get Xcode, which will be similar to Android Studio, which we're using in here. So the way you learn about making mobile applications in Android is directly related to making mobile applications for iOS. Make sense? All right, so lots of opportunities to do some cool stuff in here. That, in fact, the main reason I choose Android as opposed to iOS, even though I prefer iOS, honestly, but is I don't have to worry about what kind of computers you have. Android Studio runs on Mac and PCs and Linux and blah, 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 where Xcode only runs on the Mac, or I suppose a Hackintosh machine at various levels of success. Call it something like that.
We would never condone that in this class.
Well, I don't think there's anything illegal about it until you
use it for
until you take their operating system and install it on non-Macintosh hardware. I think the Hackintosh project itself, there's nothing illegal about that. It's when you think Apple's licensing specifically says their OSs can only run on Mac hardware or something along those lines. So that's when you would be, and I don't even know if it'd be considered illegal as opposed to a breach of terms of contract with Apple, which might mean you wouldn't get support. I don't know how it works. At the very least, it's probably unethical. But probably wouldn't be the first unethical thing you did today. We're just all being honest with ourselves. Okay, so pretty standard syllabus. Some of the stuff that's here on the topic list is a repeat to some of the stuff we've had before. So types, variables, conditionals, loops, methods, recursion. Then we start getting into stuff that we didn't necessarily deal with last time. So things like, we started talking about objects near the end of the class last time, but we'll start getting into more object-oriented stuff, inheritance, interfaces, and then I'm going to start introducing data structures in that second 8 weeks as well. So the next class, the one that comes after this, is CSC250, which is our data structures course. So we will do more data structures in there, also in the context of Android applications. So if you take 250 and 300, when you come out of there, you should be pretty proficient at writing Android software and then have all the skills you need to go and write iOS software in the context of the computer science theory stuff, which is this data structures. All right, so if you really think about this, kind of what's our, what's our trick that we do here, whether it's in this class or the game programming class, is obviously Android development sounds more fun than just writing stupid little Java programs, right? Fair enough. Writing video games using Unity sounds more fun than the computer science theory stuff. So this is almost like giving a dog a pill, right? You hide it in some good tasting food, the dog eats the food, and now he took the pill. Okay, so we kind of do the same thing in computer science. We wrap the theory stuff that you probably don't necessarily like the taste of. We wrap it inside of things that should be more fun. Some of you are going to struggle with the programming stuff, but I find that entertaining. But at the same time, it's going to be easier to swallow that in the context of, call it, fun things. Make sense? So that'll be kind of the punchline. So we'll certainly be introducing a lot of computer science theory stuff in here, and it'll just happen to be hidden inside of an assignment that seems more fun, even though you're going to be learning computer science theory by accident. We will also try to get into at least one, if not a couple, third-party APIs when we get into the Android stuff. How do we bring external things like database storage, stuff like that, or Google Maps, something. How do we bring that into our Android applications and start using other people's tools to augment our solutions? So, one thing that I say, so how many of you are a computer science IT versus computer science traditional? Who's computer science traditional in here? Okay. How many of you are IT? Okay, so the first pitch I'll make is for you IT majors. Even though the 300 course is not required, I would strongly encourage you to take it. Find a way to get it to fit in your schedule one way or another, or take it, watch the videos and do it online if it conflicts with another class. The reason is for this is I think that there's a lot of folks go into IT because they think it's not programming. All right, and I see a lot of computer science traditional students who start off in computer science traditional, then jump over to IT because they assume it's less programming. I would almost say the opposite is true. So typically, the way I kind of talk about IT versus computer science is that IT is 75% creation, 25% using what's already been created. Computer science is 75% creation, 25% using what's already been created. Okay? So as a computer scientist, most of the time we're writing our own software. But we've heard this phrase, why reinvent the wheel, right? So as a computer programmer, we're probably not going to invent Google Maps ourselves. It would make more sense for us to take this tool, Google Maps, and integrate it into our software and leverage what they've already, let's call it, perfected, right? As opposed to writing our own crappy Google Maps, a la Apple. Keep in mind, it's coming from a Mac guy, okay? Apple Maps is way better than it used to be, but Google Maps is still better. It's kind of funny. But in any case, on the IT side, fine, most of the time, 75% of the time, you're taking things that have already been built, whether it's server software or routers and the software that's on those, and you're gluing them together, you're connecting these guys to solve solutions to problems. 25% of the time, you're creating solutions, you're writing software. Well, you know what? I got news for you. The software that you're going to write is going to be far harder to write than the software that computer science people are usually writing. So when we're in here, we're going to be using Android Studio, for example, which might be a tool that a computer science person might do if they're a software engineer out in the industry or something like that. And I would actually say, in terms of examples of integrated development environments, Android Studio is not among the best. I would say it's kind of clunky at best. I just happen to use it in here because it is an industry standard tool and it'll work on all your machines, as opposed to either picking Xcode for the Mac or Visual Studio, which is PC specific. But it's fine. It doesn't completely suck. But the point is that it's a tool that makes life easier for a programmer because it's built for programmers. Well, if you're an IT professional and you're having to write software to run on a switch that's sitting underneath the floorboards halfway across campus, okay, you're not going to have a nice keyboard and mouse hooked up to this thing with a nice graphical interface for dragging and dropping interfaces. No, you're going to be remoted into this thing in a window that looks kind of like this, and you're going to be in a text-based editor like this, typing in your code and then compiling it and running it all remotely. You're not going to have friendly little tools for doing this. So the complexity of the programming you'll be doing as an IT professional, I would say, is more difficult. You have less stuff available to you for solving that problem. You're having to work with fairly, let's call it, archaic tools and gluing these two things together. They don't have a cable that just hooks them together. That makes sense? So my argument would be that programming is an essential tool for the IT professional as well as computer science professional. I fairly often argue that 300 should be part of both majors, but you only have so many classes for majors, so it's a matter of picking and choosing what do you require and then what do you promote as a good sounding elective, if that makes sense. So I would strongly encourage you to look at that. Course requirements is the typical thing for my classes for grading. 45% of your grade is going to be homework assignments. I give a lot of them. So pretty much every class you will have an assignment. They'll usually be relatively small in nature, but small is going to be an amount of time associated with it. So if you struggle with programming, you might spend 8 hours on your homework until you start catching on. If you are ahead of the curve, you might spend 20 minutes on the same assignment. Okay, so it's not that the amount of work is ridiculous. It's going to be where your competency currently is. At the end of the semester, my job is to give you a grade based on how well you've mastered the material, right? So that's why I have this other policy with the midterm and final. So halfway through the semester, we'll have a big test, and it's worth 20% of your grade. Some of you won't do well in it. So my policy is if you come back and on the final exam, you do better than you did in the midterm, I'll replace your midterm grade with whatever you got in the final exam. So you get a get out of jail free card. Okay, I do that in all my classes, no matter what class you have with me. Then we also have pop quizzes. So every now and then we'll come into class and I'll give you a quiz, and those add up to about 15% of your grade. So that's a pretty hefty chunk, and you're at the mercy of how many quizzes we end up giving. All right, so that kind of promotes attendance and that kind of stuff, because you never know the day you skip whether we'll have a quiz. You're all adults. If you have someplace better to be, it's fine. I would probably appreciate you telling me, but if it's like a legitimate excuse, you're ill, family emergency, something like that, I would let you out of a quiz. If it's, hey, I'm scheduled for work, I won't. Just real life priorities. I get it. I'm not going to be mad at you about it, but that's not a valid excuse for missing a class. So manage your work schedules, that kind of stuff. Questions about grading in the class? Pretty straightforward. Okay, so rest of this stuff is your grade breakdown: 90, 80, 70, 60. I think the bottom 2% is the minuses, top 2% is the pluses, and that kind of jazz. Okay, so let's go this route. First off, we just had we have it every year. We have this thing called the faculty retreat, where all the faculty from both campuses, the campus here as well as the campus in Ann Arbor, get together, and we kind of talk about goals for this year and weaknesses from previous years and that kind of stuff. And one thing that was advertised to you when you first came to Concordia is we are a Christian university, and Christian worldviews are going to be incorporated into the classes, and we want to start trying to do this at a more distinct level in computer science. So something I'm going to do, and I'm doing it in all my classes this semester, is each week there's actually a specific verse in each of these that I am focusing on, but I'm actually going to assign the chapter from the Bible. So you'll read this chapter from the Bible and then write a one-page, it could be double-spaced, basically a response to on how that chapter relates to your vocation, computer science or technology, something like that. Okay, so there aren't wrong answers. There may be many right answers, but effectively it's you read it, you reflect upon it, you give me your spiel as to how it relates to your major. Okay, I do realize that all of you might not be Christians, so with that in mind, from a Christian perspective, I'll let the Bible speak for itself and see if it convinces you of anything. Otherwise, you can view it as doing a book report. Okay? I understand where you're coming from, but it's a Christian school, so that's just the way it's gonna flow. So, questions about that? Okay, first assignment is already up for that, and it's due on Thursday. It's, I think, Psalm 111, so it's not real long. So it should probably I give you a link to it so you can read it online. It's probably about 3 minutes of reading. Something like that, and then write a response. Go ahead. It's the same assignment, so if you're in multiple of my classes, there's only so many verses that have to do with technology, so you get to double dip. So if you're in more than one of my classes, you'll have the exact same assignment each week. You can just turn it in for all the classes. Make sense? So if you take the game programming class, you get to double dip on that assignment. You only have to do it once a week. Okay, so let's start talking about Java. Now, I probably showed some examples last semester of Java, but we never got into Java in any sort of detail, correct? Okay, we did Python all the way through. And towards the end, we were doing objects with Python, but we really only worked with objects for a couple of weeks, something like that. All right, so let's start talking about the Java programming language in general. Okay, so Java, and we did already talk about some of this if you go back to the very beginning of last semester. Remember, we were kind of talking about the history of those different programming languages. So we talked about, we had C, then C++, then off of C++ came Java, then we had C#, and you had Swift over here, then we had our web languages, remember all that jazz? So we talked about Java at somewhat of a high level. Anybody remember about some of the things about Java or know some things about Java? What can you tell me about this language as far as what you know right now?
It's one of the most commonly used forms.
Okay, that's fair. I mean, it's certainly a popular language. I don't know about most commonly. I mean, I don't know where the exact numbers fall, but it is certainly a popular language. It's not some weird outlier. I mean, because Python's popular as well. Yeah, go ahead. Okay, so it's what's known as platform independent. So that actually takes what you said a step further. It does run on multiple systems, but more so, you write something once and it can run on any of them. So it's not just the language is supported on the different systems. It's if you write a Java program for Mac, that same program without changing anything will run on a PC, will run on Linux, will run on Unix, so on and so forth. Okay, there could be some performance differences between them, even though you wrote it the same way. You wrote it once and it ran on all four of them. Why would there be performance differences? Why might a Java program that you wrote run faster or slower on Windows than it might on a Mac? Go ahead.
Differences in how those operating systems kind of manage resources and allow programs to access memory.
Okay, I think we're getting along. I think you're correct. We're missing one layer in the middle, and that kind of has to do with how does Java accomplish its platform independence. So one of the selling points of Java, especially in the early days, was it's platform independent. That's cool. Go ahead.
Through the JVM, Java
Yeah.
Virtual Machine.
So we have this thing called the Java Virtual Machine. What is the Java Virtual Machine? What does it mean for something to be a virtual machine? We've heard that phrase before, right? Whether you've heard of the Java Virtual Machine specifically or not, we've heard this phrase of virtual machines. It's kind of become a big deal over the last probably 7, 8, 9 years. A lot of companies are using virtual machines. If you've dabbled in any sort of ethical hacking type stuff, they always want you to, well, if you're a Windows user or a Mac user, you're probably installing a virtual machine so you can get Linux on it. Because, I mean, if you do ethical hacking stuff, if you haven't had the security class with Dr. Wall, he gets into some of that stuff. You'll use a distribution of Linux called Kali Linux, which has a lot of tools in it for, the phrase is ethical hacking, which is, doing the stuff that hackers do, but do it in an ethical way.
Hacktivist.
Huh?
Hacktivist.
Hacktivist. Okay, yeah. Is that a real word? Or you just come up with that?
No,
It sounds like a
well,
real
I mean,
word.
In the 21st century, it's a real word. But
Yeah, the real issue.
Webster might not define it, but
Yeah.
yeah.
Yeah, the real issue I see with ethical hacking, and I mean I do it, but is and this kind of goes back to something that I know Dr. Locklear says pretty often, and I'm sure he heard it from somebody else, is that technology amplifies what's in our heart. Have you heard that phrase before? I mean, if you had him from 150, he probably said it something along those lines. So let's say that you do one of these courses on, not like a course we offer here where we're just going to touch on it, but I think there's this web course on YouTube that's something like 55 hours long on ethical hacking, where I mean, this guy's going into details and very specific things, specific attacks, if you will, with the idea that as an ethical hacker, you can be hired by a company to go in and test their security, right? And they'll pay you a lot of money to make sure that they're secure, so that a non-ethical hacker or an unethical hacker doesn't take advantage of them. Would be the idea. Now, the issue is that when you start learning these skill sets, now something that you previously presumed was maybe difficult, and now you either see that it's not difficult, or now you at least have the skill set in accomplishing it, it's something that you might be intrigued to do for unethical purposes, something like that. A good example would be, I would say most of us, hopefully all of us, wouldn't walk into Target and steal a DVD, right? Because the getting caught would have negative ramifications, and we think that the chance of getting caught is relatively high, something like that. But most of us in here, I'm assuming, have probably downloaded a movie or something like that off the internet. Or at least you've gotten something off the internet that you probably should have paid for, right? Why? Is there really a difference between those two? Or is it because we perceive we wouldn't get caught because it was really easy to do? Downloading a BitTorrent is simple. It's I double click on it, and 20 minutes later, I have the movie. Why go buy the ticket? I save time. It does kind of start coming down to that. Is that ethical hacking? I mean, technically, you're understanding that skill set of, I download torrent of latest movie cam. They say it's really good, and it's not in French or something like that. And now I just know what to teach people not to do. But I probably should view the movie just to make sure that I'm really dealing with the same quality product as going to the actual theater. And so I think sometimes we get pulled into the, a politician. It was a professor here several years ago who was running for Senate. Said something along the lines of nobody's incorruptible. So he was kind of advocating that there should be term limits for how long somebody should be able to stay in office, even in the Senate, because the longer you're in a position like that, the more people you owe favors to, and even with the best intentions and let's call it the best ethics, you might owe favors to the wrong people. And now you're technically corrupt, even though you didn't intend to be. You find out you're accidentally corrupt. So it becomes kind of an interesting thing. And, we can obviously have 10 hours of conversation on this topic, but, where this kind of came from in our world here is this idea of a virtual machine where, if you're running one operating system and you're going to do some ethical hacking or something like that, that encourages you to use a different operating system like Kali Linux because it has a lot of tools built into it. You might choose to download, like if you're on a Mac, Parallels, or if you're on a PC, VMware. There's several other virtual machines that are free as well. Run that on your computer. So a virtual machine is effectively an application you run on your computer that pretends to be an actual computer. Okay, so it's a software-based computer. So you download a virtual machine, it acts like a computer that you built, and then you could install Linux on that virtual machine. And what's nice about it is once you install it the first time, you could take a snapshot of it. So for the first day it worked. Okay, everything's working fine right now, so we're going to take a snapshot of that. Then you start using the machine, and let's say you break something, you get viruses, and this is even more common in workplaces with Windows users. Windows is machines that are running Windows tend to be targets of viruses and things like that. I mean, I think it's often a misnomer. I think people like to say that, Mac OS is more secure than Windows is. I mean, there might be some slight truth to that, but it's nothing that Apple did. Apple took OpenBSD Unix to make the current Mac OS. So their security came from that. If anything, insecurities were probably introduced by Apple into the operating system. So even if we say that Windows and the Mac OS are relatively secure operating systems, if you're a hacker, if you're a bad person and you're writing viruses, are you going to target the thousands and thousands and thousands of people running Windows? Are you going to pick the 7 or 8 or 9 people running Mac? You're going to pick the bigger group to target, right? So Windows has just a bigger target on its back. That's why it does have more viruses and that kind of stuff. So we could put virus protection and all these things on our machines, but they're not foolproof, right? In fact, typically the virus protection is the way we find out about the most recent viruses. So you're running Norton antivirus or McAfee or something like that on your machine, and the latest, greatest killer virus comes out. You get it. Your machine doesn't already have the way of solving it, so your machine's already under attack. It's already half the hard drive's wiped. And then it uploads the stuff to Norton and says, hey, this is a new infectious disease that all the machines are having. And then in 2 weeks, Norton releases the fix for it, and your machine's already been destroyed. And then you have to reboot and all that stuff. So what a lot of businesses are doing to save time is they have a virtual machine image for their employees to work off of. And if a certain employee's machine gets corrupt, they 5 minutes, they just dump it, reload the old the working virtual machine, and now they're back off to the races. Does that make sense? So it's a productivity tool as well. Now, with that in mind, now we get back to something that he mentioned when I asked about the performance difference between the same Java program running on a Mac versus running on a PC. Technically, that Java program is running on the Java virtual machine on the Mac, or it's running on the Java virtual machine for the PC. And those two pieces of software are not identical. They're meant to be functionally identical. They should be able to take any Java program and turn it into a working thing, but they have to be written in terms of the operating system they were written for. So the Mac Java virtual machine has to write its stuff in terms of the functions provided to it by the Mac operating system. Okay, the Mac operating system has effectively an API, an operating system API that says, here are the things that the operating system can do for you. Okay, and this is how you call them. So that Java virtual machine for the Mac had to be written with those things in mind, where even though Microsoft Windows is also an operating system, it has many, many, many similar things. They might be named different, or they might also have different ways of accomplishing the same stuff. So you have to implement that Java virtual machine in terms of that operating system. So the idea of that Java came up with, that they thought was a good idea, was, well, developers, rather than make them write their programs for Mac and then also write the program for Windows, rather than them taking the time, what we'll do is we'll just spend the upfront time and we'll write the virtual machine for Mac. We'll write the virtual machine for Windows. We'll write the virtual machine for Linux, so on and so forth. And those virtual machines, while should be very similar to each other, they should be functionally equivalent, might not have the exact same performance because they're at the mercy of the underlying technology, which is what he pointed out. They're at the one operating system might have a higher performance network stack than another operating system. So anytime you write a Java program that's going to deal with networky stuff, it's probably going to run a little quicker on the one that has the faster network stack than the other one. Okay, and then the other one might have something else that's better. So you're kind of at the mercy of that. So that's something to keep in mind when you're writing a Java program that's intended to be targeted at multiple platforms, that they might not perform identically. They should be close, or in the same ballpark. But what was the original motivation for making Java platform independent? Making, allowing a developer like us to write our software once and have it be on any of the machines. Yeah.
Wasn't it to kind of have interactive content on the web?
Actually, that's probably the thing that saved Java. That wasn't the original plan for it, but you're right. You're right. Java applets were probably the thing that kept Java in the game for a long time after its original goal didn't really pan out. So we'll come back to that in a minute. But what was the original rationale? Why did Sun Microsystems, the makers of Java, now they got bought by Oracle, so technically it's Oracle Java now. Why did they think it was a good idea to make the language platform independent? How many of you are gamers? So we'll connect this back to the game programming class. So how many of you are PC gamers as opposed to console gamers? Okay. Keep your hands up. PC gamers. Okay. Keep your hand up if you're a Mac gamer. They all went down. Why? You anti-Mac? Probably. Probably. Okay. Once you move past the emotional response to that question, why is it that you've chosen Windows as your gaming platform as opposed to Mac? Good.
Because it's just generally more used. Very few companies actually use Mac for games at all. It's rarely optimized properly for Mac.
Okay.
Windows is just sort of the standard.
Yeah, absolutely. If the new cool game is coming out, there's a 103% chance it's coming out for Windows, right? We round it up. Okay. So, and every now and then, as he pointed out, it'll also come out for Mac. Many times, a game will come out for Mac eventually.
Yeah.
right? It'll eventually come out for Mac after it's already been popular and no longer the cool kid on PC. Every now and then, you have a couple of big companies, for instance, like Blizzard might be one of them. These are companies with Activision. So these are companies with deep pockets that will, when they release a game, they release it for both platforms at the same time. But that is definitely the exception, not the rule.
And then
Go ahead.
you get the smaller games, like the indie games that can be really, really good, but they'll never appear on Mac.
Correct. Yep. So the point is as a gamer, as a computer gamer, as opposed to like an Xbox, PlayStation, those would be the console gamers. As a computer-based gamer, it makes sense. In fact, it doesn't make sense at all to be a Mac user on multiple levels. So first level, this is the most obvious, is the software that you want might not be available. Where if you're a PC gamer, the software that you want is almost definitely available. I'm sure there does exist one or two games that is Mac specific. Okay, probably not real popular ones, would be my guess. Okay, so the idea is that if you're a PC gamer, it would behoove you to use Windows. That's where all the games are going to be. Secondarily, as a gamer, you like your stuff to be high performance, right? Because PC gamers they fall into this category called enthusiasts. They're enthusiast users for their machines, typically limited by the size of your wallet. Okay, so all of you PC gamers out there, if you had unlimited funds, you would have the fastest processors, the most memory, the fastest hard drives, and the best graphics cards, right? Probably multiples of them. Okay, if money was no object, okay, because you're enthusiasts. Realistically, what do? You get the very, 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 very best that you can afford. That's what you end up doing, right? But it's a priority for you to get those machines because the better your gaming rig is, the better it'll drive those games. Okay, we go into a lot more detail about this in the game programming class. Another pitch. But in any case, another reason why PC gaming makes a whole lot more sense than Mac gaming anyways, besides the availability of the software, is Apple has always been kind of that design innovation type thing, right? If you look around the room, okay, so this is the latest MacBook Pro, okay? You would be hard pressed to find another laptop from any company that is built structurally better, right? Apple makes their stuff crazy thin, and it's made from crazy materials that they mine from Mars or something like that. Okay, at the cost of being a lot more expensive, but also at the cost of being significantly less upgradable. Now, laptops in their own nature are typically not as upgradable as a desktop would be. So let's look at Apple's desktop world. Okay, so you want to buy an Apple desktop, you're probably buying an iMac, or you're buying a Mac Pro, which has been a disaster, the recent Mac Pro. But the reality is neither of those are upgradable. If you bought a iMac 2 years ago, and it had the best graphics card that came with an iMac 2 years ago, there's no upgrading that. End of the road. You want a better graphics card? Buy a new Mac. It's expensive. Okay. Now, just recently, Apple started to create a path for upgrading. It's not a perfect path, and I'm not even sure it's a smart path, but it is a path. They have this thing called Thunderbolt 3 that is only in the newest Macs. So this is only something that you can get from this point forward, let's say, and that is you can get an external graphics card. You can get a case. Now, you pay $300 just for a case that connects to your computer that can hold a graphics card. It doesn't come with a graphics card. So just a case for the graphics card. Okay. Then you spend the $700 for the graphics card. Okay. So now you got $1,000, but it'll plug into your Mac and it will give you a faster GPU. You'll have a faster graphics card now in your Mac. But you won't have the games. So maybe we fast forward 3 years, you might see more games come out for both since they'll be able to be written for the same graphic hardware. But regardless, generally speaking, Macs are not upgradable from a graphics hardware idea. For you PC gamers who probably built your own, gaming computer, right? It's a tower. whatever was the best tower you could afford, and you might have liquid cooling, you might have not, whatever it is. But if a year from now you feel your machine is getting a little sluggish, you can't really keep up with the games you want to play, all you have to upgrade is the graphics card, right? You sell your current card on eBay, get something out of it, drop another $300 or $400 and get a lot better graphics card than you previously had, and now all of a sudden your machine is good again for a while, right? No big deal. Fine, it was $300 or $400 that you could have spent on something else, but at least you have a path to upgrade. So there's a whole lot of reasons, if you're a PC gamer, to be running Windows. That's where the software is available, and that's also where you have the most flexibility with the hardware. Apple controls their ecosystem. So now we get back to the motivation of why the Java people, why Sun Microsystems decided Java really needs to be platform independent. Now, this shouldn't come as any surprise to you, but it's, once again, the Mac people ruined it for us. Okay? You're sitting out there, it's like, well, you're a Mac guy. You're sitting with an Apple in front of you. See, I teach computer science. I write software for a lot of different platforms. So I used to say this was 2 computers for the price of 1.7, because I dual boot Windows on this as well. Now I can say with the new pricing plan, it's 2 computers for the price of 2.2. So now it's more of a thing, I just don't have to carry 2 laptops is what it comes down to. Now that Apple, they price these things ridiculously. It's like a $5,000 laptop. And it doesn't have the newest stuff. This has like a year ago's technology in it. It's ridiculous. Yeah.
A little further about Apple, they are really not unhappy with anyone touching their stuff but them.
Oh, absolutely. That's how they've always been.
Yeah, they hide all of their information. They try their best to keep any third party from even learning.
Mm-hmm. Well, here I'll throw a curveball at you. Do you think Apple should do that? Do you think that's wrong of them to do?
I think they have the right to do it. I still think it's a crappy move.
So you would say it's a crappy business model?
Not necessarily, but that it's just, they have the right to do it, but they shouldn't.
Did you know that Apple tried that years and years ago?
Really?
Yeah. You probably were barely a thing, but you maybe weren't much of a thing. You maybe were 2 or something. But Apple did. They tried to make their stuff less proprietary. They started letting other companies make Macintosh clones, stuff like that, and they almost failed as a company. True story.
It's not so much that, it's more of just people repairing them.
Yeah, so what it came down to is Apple has had their success based on their proprietary nature. And that's why you have this division of users. So people who love Apple say, well, I just want my stuff to work. I don't care if I don't have control, right? People who hate Apple, it's like, look, I want to have control. I don't care if the interface is not quite as clean or something like that. But I don't want Apple to be making all my decisions for me. I want to be able to make a choice. And when this doesn't work, it's not because it's Android's fault or because it's Microsoft's fault. It's because I installed some software because it was my choice to install it and I screwed my system up. That's what happened, but it was on me. Yeah.
Well, on that, they've only really been doing that since the Macintosh came out, because the Apple II, it actually came
with DOS, yeah.
Diagram of the motherboard
Sure.
in the manual.
Yeah, but that's what we're talking about with modern Apple. Actually, modern Apple isn't even that. Modern Apple is actually Next Computers with an Apple logo on it. So modern Apple is when Apple fired Steve Jobs, then acquired Next Computers, the company Steve Jobs founded. They brought, have I told you this story before? Oh, so this is an interesting one. So Apple fired Steve Jobs, right? And then Apple started failing as a company. During the time when Steve Jobs was gone, Apple was, they were starting to become less proprietary and basically failing as a company. So during that time, Steve Jobs, founder of Apple, went and started another company called Next Computers, where he wanted it to be a cross-platform thing, so it was kind of the best of both worlds. Mac and Windows stuff all in one machine, kind of compatible with both. This was during a period of time where you couldn't put a disk from a Macintosh computer into a PC without it saying, I want to format this. Okay, you couldn't share files between the two of them. Well, Next computers didn't necessarily take off in the consumer space itself, but it was pretty successful in education. You know, they were expensive machines. Well, what happened is Apple didn't go back and rehire Steve Jobs. You know, that's a common misconception. What Apple did is they acquired Next Computers. And what came with that is Next Computers' CEO, which was Steve Jobs. Apple then installed their CEO, Steve Jobs, as the interim CEO, the iCEO, when he started naming everything, you know, iPod, iMac, iBook, and all that stuff. And then he finally became the old the full-time CEO of Apple. But Apple today is Next Computers. You can see it right in their software. If you look at Objective-C, so the Apple programming language before Swift, if you want to look at a string, if you're writing some software and you want to define a string in Objective-C, it's called an NS string, next step string. So it's the operating system that we're using today, Mac OS X, is the next operating system with a let's call it an Apple beautiful front end on it or something like that. So that's what we're using today, is Next Computers with an Apple logo. It's kind of an interesting history of it. But what I was getting at before is that, you know, once again, the Apple people ruined it for the rest of us. And how did they do that? Well, back then, you had, you know, so this is in the early days of Java, so let's call it the mid-90s, 95, 96. Some of you were things, barely things, right? So 95, 96, and, you know, games were starting to become a thing on computers. Computers have really only been out like consumer grade for, you know, maybe 10 years, something like that, where people could like actually afford them. But they didn't, it only recently had like the internet become like sort of kind of a thing. It wasn't popular yet, but it was a thing. So you started having this reason for people to play games. And what did you, so, you know, you have a zillion people running Windows, you know, at that time, probably running Windows 3.1. And then you had not a zillion people running probably at that time Mac OS 7 maybe. Could it be? Actually, could have still been Mac OS 6, whatever it was. So what did the Macintosh people say? It's like, well, the software's not coming out for us. We don't understand why. You know, all 10 of them. And the zillion people over here were like, oh, we got all the software we want. Everything's good. Well, Sun Microsystems was a little bit more in the Macintosh corner, the Apple corner. So they said, oh, well, we want to make those couple people happy too. So we're going to create a language where we encourage, really the original idea was for games. We'll encourage people to, video game makers, to write their software in Java so that when the game comes out, it'll run on both. Sounds good on paper. Problem is, as he pointed out earlier, you're going through a middleman. And that Java virtual machine for Mac might not be equivalent to the Java virtual machine for the PC in terms of performance. And at the very least, in both cases, now you're going through a translator. You're writing your software for this virtual machine, which then translates into something native for the computer. So any way you cut it, you're slowing it down, right? So now the game that used to run faster is now slowed down by, we'll throw a number at it, 20%. We'll say it's 20% slower now on the PC, just so those 10 people on the Mac can have also a slowed down game. And then as our computer hardware got better and better and better and better, that slowdown meant more to us, right? All of a sudden, we're not even directly accessing our graphics cards anymore. And now we're that 20% is actually more like an 80% slowdown, to the point that today, how many companies release, let's call them real video games? I mean, things like Angry Birds, that kind of stuff that they're fun games. They're kind of time waster type games. We have low expectations of performance from those. We're not measuring Angry Birds in terms of frames per second. Okay, you're not sitting there with your PC running Angry Birds on a Chromebook saying, oh yeah, I'm getting 4,500 frames a second on this. You probably could get 4,500 frames a second on Angry Birds. Okay, that's not a priority for games like that. But if you're running, latest Battlefield or something like that, okay, how many games like that are written in Java? 0. But it could be available on both platforms. We don't care, first of all, because these guys have the money they're paying us, okay? And half of the guys over here are just going to steal it. Well, really, half of the guys on both sides are going to steal it. So we're only getting half the money from the bigger side, is the reality. Okay, Java didn't fit that niche. It sounded good on paper, and it's fine for web games. We do see it. That's kind of where you were going before. Is we have a lot of interactivity stuff on the web. So you have Java applets is kind of the technology that kept Java around. Which is effectively a Java program that runs within the web browser. So you have a lot of software that's written for that. So you really have probably 2 reasons, if we kind of had to point at 2 big reasons why Java didn't kind of fizzle out. I can maybe throw a third one in there. The third one would probably be education. There is an advantage from an education perspective to have one language that is a good language. So the syntax for Java is an upgrade to the syntax of C++, which is an upgrade to the syntax of C. So this is, and if you know Java, you already pretty much know C#. They're almost identical languages because once upon a time, Microsoft tried to steal Java. They got sued. They lost. They came out with C#, which is basically Java with slightly different syntax. I mean slightly. Just the minimum amount of difference that needed to not get sued again. But, the punchline is Java is a good language for development, not game development, but for business development, certainly. Because again, we're not, things like Microsoft Word, we're not measuring that in frames per second either, right? It either works or it doesn't work. These aren't high graphical horsepower type things. Java's appropriate for cross-platform business applications. It's not appropriate for cross-platform games. Okay, but education is a big thing because if I teach Java, then I don't have to worry about what kind of machines you guys are using. Okay, yes, we have a nice lab down there, blah, 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 but you all have your own computers. You don't want to have to come and do your homework in the lab if you don't have to, right? And I realize that. So you would probably be upset with me if all your assignments were on the Mac. You had to write iOS apps for everything because only those of you who actually own a Mac are going to be able to do your homework at home. And the rest of you are going to not be happy with me because you have to come in and use the lab. Fair enough? Okay, so I like Java. In fact, I probably like Java better than I like Swift. So I have all sorts of problems with, all sorts of complaints about Swift. You'll hear me complain about that a lot in the 470 class when you finally have it with me. I'm offering it this semester, but it's a upper division 1 where we write a programming language in there. And Swift is just a crap language because they tried to be everything to everyone. I think I probably talked about at the beginning of last semester the rationale why Swift came out. Swift did not come out because the Apple people were complaining about Objective-C. So if you were a Mac developer, you were writing all your software in Objective-C before Swift. Those people are already drinking the Kool-Aid. They're happy with Objective-C. I like Objective-C quite a bit. I like it a lot better than Swift. But Swift looks a whole lot like Java. And who's writing Java stuff? The Android developers. So what is Swift there for? Swift is there to say, hey, Android developers, why don't you come over and write your software for iOS? You can make more money. Hey, web developers, why don't you come over and start writing stuff in for Swift for iOS or for the Mac instead of an HTML5 and that kind of stuff. So it was about getting other people over to the Mac platform. So they tried to be everything to everyone. And now what they're doing in later versions of Swift is they're taking away features they originally put in. Because now you already, we've been fishing. We got enough people over to the dark side now. We're not getting to now it's a trickle. So we'll go ahead and just take away some of the stuff they were used to. And now you got to deal with a core language. This is what the language was supposed to be. But we wouldn't have been able to convince you with that. It's like McDonald's get you into the door with 2-for-1 Big Macs, and then all of a sudden they increase the price of a Big Mac, and now they don't have 2-for-1 price anymore. Got to recoup the money in that.
How do you remove feature from a language?
Say this again.
How do you remove feature?
For example, there was for loops. There was about 5 different ways of writing for loops in Swift.
Fundamental stuff.
No, a for loop still exists in Swift, but now it's just one for loop. instead of a for loop that looks like a JavaScript for each loop, or a for loop that looks like a Python loop, or a for loop that looks like a C++ loop. They had the same loop with 5 different syntaxes to make it comfortable for people who use these other technologies to jump ship. Make sense? Yeah.
So, given that Java is terrible for game development, why, and that C# is pretty much a copy of Java, why is C# the language of choice for Unity?
Well, first of all, that's the scripting language for Unity. Unity itself is written in C++. But C# does have one difference. In fact, pause that for a second. Let me give you the 3 reasons that Java stayed alive, but then I do want to answer because it's an important reason. So if I forget in 3 minutes, remind me again. Okay, so one thing is education for why Java stuck around. I can teach a class and I don't have to worry about what kind of machines you guys have. Another thing is Google. Okay, Google was a Java shop for a long, long time. Really still is. Okay, they use Python quite a bit as well, and now they have some of their own technologies, but you see it with Android. Android development language is Java. So Google was a Java shop. Why? Was it because they just loved Java? Doubtful. Because they hated Microsoft. Okay? They wouldn't admit to that, but it's true. They're competitors, right? So they kept Java afloat, let's say. Now the other thing, and this is big industry, and this is big money. If you do any sort of stock investment stuff, so go to E-Trade's website, for example. E-Trade is going to brag about this pro investor tool that they have that you can either pay $199 a month for or something like that, or if you have enough money in your account you're investing with, you get it for free. And what it is, it's a real-time stock market investing tool that gives you real-time quotes, the ability to make your own trades, stuff like that. Powerful stuff for people who are trying to make money as like day traders. That's all written in Java. It's a Java applet. So it's a program that launches out of a web page. So they only had to write that once and get it right once. And it runs on the Mac, it runs on Linux, it runs on PC. So that's big dollars associated with one business application that is really ubiquitous with the people who have money. That makes sense? And people who have money carry a whole lot more weight than 5 times more people who have less money. Because companies like money. If they can make money, they like that. I assume most of you probably like money too. If you're a fan, especially those the game rigs that need a little love for the graphics card and get to use a little bit extra money. So those are really the 3 reasons why Java probably stayed afloat, and now it's found its niche. So I think Java stands on its own now. Now with the whole C# argument, C#, and let's actually throw this in here. C# also claims to be platform independent. So I mentioned that C#, originally Microsoft tried to steal Java. They released a product called J++, which was Java syntax using a Java virtual machine that was written by Microsoft. That had a little bit better performance on the Microsoft on the Microsoft platform. But then they got sued. They lost. They had to come up with a language. So they wanted to take everything that was good about Java. And then they, so syntactically it looks pretty much the same, but that really isn't stealing from Java. That's really both of them stealing from C++. And that's that guy stealing from C. I mean, those languages look the same. All right. But Microsoft looked at the platform independence issue of Java, which we've discussed today, right? And we've seen the kind of the pros and cons of it. And they said, you know what? We can make that better. We'll make ours platform independent, but because we're Microsoft, it must be better, right? So C# is platform independent as long as you have the .NET component architecture. Say, look, it's platform independent, people. It'll run on any platform as long as it's Windows.
You'll get in any color as long as it's black.
Exactly. Okay. Now, this is about to become a little bit less true because they are porting the .NET component architecture now over to the Mac. Because actually, really today, Microsoft and Apple are probably less in competition than they've ever been in terms of direct competition. They both they found their footing, and really what's happened is Microsoft failed in the mobile market. And they still have Windows Mobile, but nobody uses Windows Mobile. We really have two players. To be honest, most people I know who have a Windows Mobile device like it. So it really probably had more to do with Microsoft was just too late to the game. I mean, there's really only two players in mobile platforms. That's iOS and Android, right? I mean, does anybody have a strong disagreement to that? I mean, the numbers don't lie, but I mean, you have two pretty strong competitors, and you got this other guy. So really now, Microsoft doesn't really have a horse in that race. So what they're trying to do is they have a product that they're working on called Xamarin. How many of you have heard of Xamarin? Okay. Xamarin is a cross-platform development tool that will allow you to use C# to write iOS and Android apps. Some companies are using it. I haven't been impressed with it yet. Historically, cross-platform tools, you give up something. But if Microsoft keeps going down that line, it's possible that could be a success. Where now they can still benefit from Android and iOS by being the main mechanism of development for them. I don't see that happening, but that is possible that could happen. We have a former grad student from here who works in a company in Milwaukee, and he spends all day writing Xamarin code. So as long as the stuff that you're writing for mobile isn't overly complex, because whenever you're using a tool that deploys to both platforms, you're having to deal with the lowest common denominator between the two of them. So, if iOS has this feature and Android does not, then you either have to say, well, my product only works on iOS if I want that feature, or I can't use that feature in my development because one of my platforms doesn't support it. Something along those lines. But the advantage of this, so I was saying that they're starting to come over and because they're in less competition with Apple. But now C#, the reason why, from the platform independence perspective, it is better than Java. And this is kind of to your question of why do they tell people to use C#. It's less about the Unity side of things. They just pick that as their scripting language because the way the scripts run in there it's not natively running. It's a little different. But, let's say a video game. I would say most games today are still written in C++, but more and more are being written in C#. It's not uncommon today for a game to be written in C#. And the reason for that is when you run a C# application for the first time on Windows, it uses something called a JIT, a just-in-time compiler. All right. Anybody remember what a compiler is? What's the definition of a compiler? We talked about last semester. Go ahead.
From high-level language to low-level language.
Okay, so it translates from a high-level language to a low-level language. And we need them because human beings, we like to write things in high-level languages where we have a many-to-one relationship with the CPU, right? We're certainly not going to write zeros and ones. Not our style. And if we can help it, we don't want to write every little tiny instruction for every little thing we want the CPU to do. When you take the 325 class and we do assembly language programming, you'll see how you definitely would not want to, even the hello world program in that is lots of, I think I probably showed it last semester, didn't I? It's lots of, it means 30 lines of code or 20 lines of code. It's more than one line of code. It's many lines of code you're writing. Okay, so with that in mind, your preference would be to write in a high-level language, like Java, like Python, like C#, where you can accomplish a whole lot of stuff in one line. But at the end of the day, your computer needs it in zeros and ones. So a compiler takes that high-level language, turns it into a low-level language. So it'll take Java or C# and turn it into assembly. And then the linker at runtime will convert the assembly into zeros and ones, the actual instructions for the CPU. And the CPU goes off and does its little tasks. And it does these little granular tasks a whole bunch of times per second. And you do these little tiny tasks in a row, you've actually accomplished something big. even though it maybe didn't seem like it at any individual point in time. Okay, well, C# uses this just-in-time compiler the very first time you run your application. So the very, very first time you launch a C# application on your computer, it'll take a little bit longer to launch, because what it's doing is it's taking the equivalent to a Java class file that we'll see. So Java has a compiler. It compiles from Java down to something called Java bytecode. And then that Java bytecode runs natively on the Java virtual machine, which then translates it into native code for the hardware. .NET takes your C# code, so C# takes C# code, converts it into something called MISL code, Microsoft Intermediate Language, MSIL. Now, that's basically the same as Java bytecode, just a different name. Okay? It's an intermediate language. Now, the difference is every single time you run a Java program, the Java bytecode gets translated into native stuff. For a C# program, the very first time you run it, the MISL code gets turned into native assembly code. Now, every time you run it after that, it just runs the native assembly code as if it was written that way to begin with. So the speed of a C# program is the efficiency, let's say, of a C# program isn't hurt by the fact that it was supposedly platform independent. Instead, the only thing that might, I'll ask the question out loud. Why might a program written in C#, since it ultimately becomes native assembly language for the processor, why might that not be as efficient as a program written in C++? So I write a program in C++, I compile it, it's native assembly right off the bat. I write a program in C#, it goes through the compiler, and at the first time I run it, it turns into native code for that platform. Why might the C++ still be faster? How many of you speak a different language? Have more language than just English? Okay. How many of you have ever used Google Translate to translate something from one language to another? What would you, if you had to give a letter grade to the accuracy, what would you say? C? Okay. Okay, so fairly often it doesn't quite get it quite right. Is that a fair enough statement? Sometimes it gets it horrifically wrong. Those are the funny ones that you see about, you go on the internet and say funny Google Translate things or something like that. But why is that? Because you write something, first of all, natural languages are more difficult because a natural language has nuance. So if you try to translate something in a natural language to another natural language, like English to German or something like that, okay, there's lots of nuances to these languages where you have to figure out meaning, the semantics of what was trying to be said rather than the exact words. Where a programming language is much more discrete. We can look at the exact syntax you wrote and make a decision about what you were actually saying. Okay, so syntaxes should be easier. Now, the catch here though is you're at the mercy of that .NET component that takes the Microsoft Intermediate Language and converts it into native assembly language. You're at the mercy of how well it translates that. Now, I've already said that programming syntax is unambiguous. Therefore, it should be able to do an accurate job of translating it. Okay, you shouldn't have this. It should always be A-level work in terms of accuracy. But let's assume Google Translate does translate it correctly. Let's say you have statement English, it translates it to German. Is what it translated always going to be the most efficient way of saying that in German? Or might there be an alternative way of phrasing that in German that would actually be more efficient than the English equivalent? Is that a real possibility? Okay. Same thing's true in programming. So if you take a MISL code, Microsoft Intermediate Language, and you translate it into assembly code, okay, which is a low-level language, that assembly code will be accurate, but it might not be the most efficient. And the thing is, you don't have the opportunity at that point in time to make modifications to it. Wherein, and we'll see plenty of examples of this during the semester, but in a language like C++, when you write the program initially and then you compile it, it's going to dump out a bunch of assembly code. Now, as a programmer, you can go in, and Java is really nitpicky about this. Java is very specific about forcing you to write something. Here's an example. Let's say you're writing some code, and you have stuff, because you know the nature of what your program's going to do, you know the nature of the data that's coming into it, you might have logic up here that you know will deal with 100% of the inputs, the valid inputs. Java will say, well, you have to have an else to that, because what if you get down here? Now, you might know, I'm never getting down there. Okay? The data that's coming in will always keep me up in this logic. But Java won't compile your program. It won't say you're good until you've written the secondary case that you know is a waste of time. But Java doesn't know that. It doesn't know what your data is going to look like coming into this. So Java is going to force you to write it. And then what you're going to get is you're going to get an inefficient output, even though it's an accurate output, because you're going to have a chunk of Java bytecode that will never be used because you know the nature of your program. Same thing's true in C++. C++ is a little bit less picky about what it will force you to write because it's perfectly happy with your code crashing your machine. But it'll also, after you compiled C++ code and you have assembly language, you can go into that assembly language and manipulate it. You can change it. You can even actually insert assembly code into your C++ program and say, don't compile this, just use this code as is. Because you might say, okay, the compiler turned it into this. Now this is accurate, but it has some extra fluff in it, extra checking that doesn't need to happen. So I'm going to turn this into this. So you're going to go and cut down on the number of checking, or you're going to speed up that little chunk of assembly code because you know you can, because you know the nature of the data that's coming through it. It's not that what was produced was inaccurate. It just wasn't as efficient as it could be for the exact problem that you were solving. Make sense? Now, I'm not saying it's impossible to do that in C#, but because the C# program is launching on the consumer's computer, okay, so the very first time that it launches is when the consumer double clicks on it. The programmer didn't have the opportunity to interject changes to, and there are some workarounds to that. There's some things that you can do in C# to kind of force your will on the output. But in general, C++ has that built in. And especially if you're not taking it, already we see that C#, even though they say it's platform independent, really is not platform independent. Correct? You got to run Windows. It's platform independent as long as you're running Windows. Therefore, if you're writing a game and it's targeting Windows, why not write it on the code that will give you the most flexibility? All right. C# does give us some access to some tools that might otherwise not be available in C++ or very difficult to integrate into a more modern program because it was written in a let's call it a more archaic language. Sometimes taking two different technologies and getting them to talk together might not work as well as you want it to. So there is some pressure now for companies to begin their development in a more modern language like C# and rely on the quality of our compilers to make that translation as efficient as possible. Okay, so that's kind of where C# stands. Whether you're learning Java or you're learning C# really doesn't make any difference. Okay, programming is programming. It's a skill set, and like I said last semester, I want you to think about it like a sport. Okay, some of you already feel like you've gotten somewhere with it. Maybe you felt like you got pretty good at it last semester. Some of you might still think, hey, this is just not my cup of tea. Got to keep putting the time in. If you ask yourself, am I putting enough time into practicing my programming? This is where it goes back to thinking about it like a sport. Pick your favorite sport and say, if I spent the same amount of time on that sport as I'm spending on my programming, how would I expect myself to improve? If you're spending 20 minutes a week on soccer, you're probably not going to get a whole lot better at soccer, right? In fact, you're probably going to fall out of shape and get worse at soccer. So something along those lines. So be prepared to spend a lot of time on your assignments. And those of you who are kind of ahead of the game and feel like the assignments are almost too easy early on, challenge yourself. Add some features to it to make it more difficult. Because keep in mind, this is about your career, what you're going to end up, what your capabilities are going to be when you get out of school and you go and work someplace. And they don't care if you met the bare minimum requirements in school. I get paid either way. I deliver the information to you, and whether you've learned it or not is whatever. So you got to make school, make out of school what you can. Just this last semester, we had 3 people went up and worked at Acuity up in Sheboygan, which is actually they have a working Ferris wheel in the building. It's like really cool. And they have rock climbing wall. I mean, it's almost like Google, the way it feels. They're making really good money right out of school, and these were those students that always went the extra mile on their programming stuff, got involved in projects outside of what was in the classroom, that kind of stuff. So I guess take that for what it is. All right, so first homework assignment is up. We'll come back on Thursday. We'll pick up where we left off here, and hopefully we'll start introducing Eclipse, the programming environment we're going to start off using. I will see everybody on Thursday. Don't forget, if you're interested in the game programming class, sign up for it or come up and talk to me, and I'll give you my 2 cents.